Okay, in this section, we will learn what the relations and functions are. Okay, the definition of relation is a set of all order pairs. Relation is a set of all order pairs. So we have x, y, an x component, y component. And from this order pair, the first component is the x values, the second component is the y values. And the first component set of all these first components is called domain. Okay, domain. The x values of the order pairs. And this x value, the domain is also an input, set of all inputs. So once, like y equals 2x plus 1. For example, y equals 2x plus 1. Then all the values of x are input, and from each input, evaluate this expression, then the result is the y value. So the result is called the range. So range is the output. So the output is the y values. So the y values are the second component of the order pair. So range is actually the set of the y values. So let's do some examples. Okay, what would be the domain? Okay, example 1. What would be the domain of this set and the range of this set? Because the domain has an order pairs. So 0, 1, 1 and 3, 2 and 5, 3 and 5, and 0 and 3. Okay, so there are 1, 2, 3, 4, 5 order pairs. Then the domain is a set of all the x values 0, 0, 1, 2, 3, and 0. But this 0 is already included here, so you don't have to write another one. If there is a multiple number, then use only one number. So 0, 1, 2, 3 is the domain. How about the range? The range is all set up all the y values. So here is 1, 3, 5, and here's another 5. So we just write 1, 5 only. So 1, 3, 5 is they are the element of the range. So set of 1, 3, and 5 is the range. Set of 0, 1, 2, 3 is the domain. Okay, for a definition of functions, let me draw a little diagram. Okay, let me draw a little box that has 2 holes in it. Okay, so let's say the box name is f of x. So I don't know what this f of x is, but this is a magic box. You put an input. Let's say x is an input. X can be 1, 2, 3, any number. So a number goes inside the box, and this box will process that it produce something with this input and gives the output. And this output value is y. So one input value goes inside the box, and then this box generates an output, and the output value, there's only one output comes out. So this is function. So give one input and you get one output. Once you give one input, then you cannot have 2 outputs. You must have only one output. So let me draw 2 circles. Okay, let's say this is set A, set of inputs. Set of inputs is the domain. We call it a domain. And set of outputs, these are the set of outputs. We call it range. So let's say here is input values 1, 2, 3, and output values, let's say 5, 4, 3. And then for input 1, if we put 1 as an input into the box f of x, let's say this is f of x, and this one gives you the result, the output, let's say 5. Okay, so one input, the value 1, which is an input, has y value, output 5. How about 2? Let's say okay, you put in this number into the box, then let's say the result is 5. How about 3? So 3 is an input, then the result is 3. Okay, then this is a function. It's a relation. So relation is for input, there is an output. For input, there's an output. For input, there's output. And function means okay, for each input, it must have exactly one output. So 2 has one output 5. The input 2 has, the input 1 has number 5 as an output. The input number 2 has an output number 5. Also, input 3 has an output, which is number 3. So this is a function. Okay, let's try an example of another function. Well, a function that is not a function. Here it is set x, set y, and the relation is f of x. The relation is a box. Just 1, 2, 3, 5, 4, 3. Okay, the input 1 is matched with 5, and number 2 is matched with 4, and also 1 matches with 3, and 3 matches 3. Is this a function? This is not a function, because the input 2, look at the input. This input has 2 y values. This input has 2 y values. One is 4, one is 3. We must have only one output. So these 2 must have only one output. You cannot have 2. So this is not a function. How about this? Set domain, this is the range. We do the similar, okay, we will have the similar information. Okay, the relation is f of x. Relation is f of x, so this is not right. From x to y. Okay, let's say 1 goes to 4, 2 goes to 4, 3 goes to 4. Is this a function? Think. Each element in the domain is matched with only one output? Yes. Yes. So this is a function. This is a function because okay, 1 matches with 1 has only one output 4. 2 has only one output. 3 has only one output. It doesn't matter whether the output has many inputs. It doesn't matter. The important thing is each input must have only one output. So this is yes, this is a function. Okay, in this example, let's determine whether each description represents a function. Okay, the number 1. The input value x is any of the 50 states in the United States. So, each state has different number of or same number of governors. So, it is unique. For each input, for each state, there is only one number of governors. The number of governors is fixed. So you cannot have 2. So there is one for each input x, there is only one y value. So yes, this is a function. Yes, this is a function. How about number 2? Okay, let's check the input. Input is the first component. Input is 1. 1 has a value. 2, 3, 4, 5, 6. So there are each order pair has input, which is x value, and each x value has only one output. So yes, this is a function. Okay, how about number 3? Number 3, the input. Input 1, negative 1 has 7, okay. 3 has 2, 4 has 2, but here's another 3, the input. This 3 has 2 and 3 has 4. So this means number 3 has, the input 3 has 2 outputs, 2 and 4. So this is not a function. Okay, how about A? So the relation from A to B is, okay, this input A has output 1 and 2. This is not a function, because input must have only one output, but it has 2 outputs. Even this one, the input B has 2 outputs, 3 and 4, so it's not a function. Okay, in this example, there are 3 equations that we want to find out which equation represents y as a function of x. Okay, what do you mean by y as a function of x? This means x is the input. X is the input and y is the output. X is the input, y is the input. So set of x values are the domain, set of y values are the range. Okay, so we can write it as f of x. F of x. So function equation is a function of input value x. Function f, and whose input is an x. So function of x, f of x. Okay, the input, x is the input, and also we call this variable is called independent variable. So x is the independent variable. We call it independent variable. And y depends on the input. Y depends on the input, so y is a dependent variable. All right. So function of x means x is an input, and f of x, which is y is the output, and the input variable is called x is called independent variable, and y is called dependent variable, because the y value, the output, depends on the input x. Okay, so let's check the first equation. Okay, y equals x squared plus 1. Okay, in order for this to be a function, there must have one output for each input, exactly one output for each input. So what is the graph of this? The graph is, we will learn this graph. The graph looks like this. So if x equals 0, then y equals, x equals 0, y is 1, x equals 1, then y is 2, x equals 3, 2, then we have some y value, x equals negative 1, also there is one y value. So 1x, there's 1y, 1x, 1y. So this is a function. Yes, this is a function. How about the second equation? Okay, let's try x equals 0, the input x equals 0, and let's find y. If there are 2 y values, then this is not a function. So if x equals 0, then 0 minus y squared equals 2, negative y squared equals negative 2. In this case, y squared is equal to positive 2. Then what is y? Y is positive square root of 2 or negative square root of 2. Sorry about this one. Okay, y is negative, y squared is negative. Y squared is negative, then there is no solution in this case. So I used wrong input. So this is not a good input value. Let's try an input value 6. Okay, let's try 6. X equals 6. Then we must have only one y value. So this is not a good example. X equals 0 is not a good example. So let's use x equals 6. Then 6 minus y squared equals 2. Then negative y squared is equal to minus 6 each side, negative 4. Then y squared is equal to 4. Okay, y squared is 4. Then what are the y values? Y is 2. Then 2 squared is 4. Y is negative 2. So negative 2 squared is also 4. So there are two y values. Input is 6. Input is 6, but 6 has two outputs. One is 2 and negative 2. So this is not a function. So this is not a function. How about the third one? Okay, third one is an equation, linear equation. So linear equation, so it's a straight line. It's a straight line. So when you graph this one, x equals 0, then y is x equals 0, y is 4/3. And y equals 0, then x equals negative 2. Y equals 0, then x is negative 2. This is a straight line. So for this straight line, for each x value, there is only one y value. For this point, for x equals 1, here's a y value, x equals 2, another y value, x equals 3. So each x value matches with only one y value. So this is, yes, this is a function. Okay, then if there is a graph, then we can check whether the graph is a function. It satisfies the function definition. So let's say here's a graph, something like this. And here's a graph, something like this. And here's another graph, this time like this. Here's a graph, something like this. Okay, then is this function? Is this graph function? This one is yes, because one easy way to determine whether a graph is a function, draw a vertical line. Draw a vertical line, and if the vertical line intersects with only one point, then this is a function. How about this? Draw a vertical line, then this vertical line has only one point. So this is function. How about this one? Yes, of course, this is also a function. How about okay, number 3 is a function, number 4. How about this one? This is not a function because draw a vertical line, then this line, okay, for this input, there are two y values. So this is not a function. So in order to check if a graph satisfies a function, then draw a vertical line. If the vertical line intersects with 2 points or more than 1 point, then it's not a function. It must intersect at 1 point. Then it is a function. Okay, in this example, we will learn the function notation. Okay, usually the function notation we write something like this: f parenthesis x and parenthesis. So this means f is the name of the function. You can use g of x, k of x, or h of x. So f is the name of the function, and the variable x is the input. X is the input, and also is a domain. So set of all input is a domain. So x is an input, and then you evaluate the expression for this function, then the result, which is f of x. So f of x, this is the output. So output is the range. Okay, so how do you read this one? Just read it as f of x, which means x is the input, and the result is the output. Or you can write it, you can read it as, so this is the value of f, the value of f, the function, when x equals x. So the value of f at x equals x. So f of x is a function notation. Usually you can write this one as y, because y equals something. And this y is, the expression is in terms of x. So by giving an x value, evaluate it, and then the result is the value of y. So it's the value of f, the function. Okay, then here is a function g of x. Okay, g of x is 3x minus 4. Okay, let's find the value of this function g, the value of this g. So g of 1 means the input is 1. So the input is x. So in this case, rewrite this x with input 1. Then the function is 3x minus 4. So write down so g of 1 is equal to, what we have to do is just replace this x. Replace the x with 1. Replace the x with 1. Replace this x with 1. Then 3 times 1 minus 4 equals 3 minus 4, so negative 1. So the value of this function is negative 1 at x equals 1. Okay, how about number 2? G of negative 2. Just plug in negative 2. So 3 times x is negative 2 minus 4. Then negative 6 minus 4 equals negative 10. So the output is negative 10 when the input x is negative 2. Okay, how about the number 3? Okay, g of y. G of y means the input x will be replaced with this y. So replace x with y, then the expression will be 3y minus 4. So this is the g value, the expression for this g of y. Okay, how about number 4? Number 4, the same thing. The input is this time x plus 1. This is the input. So we have to substitute this input x plus 1 with x in the original function. So x will be replaced by this input. That input is x plus 1 minus 4. Okay, so g of x is 3x minus 1. What we are doing is replace this x, which is this one, with the given input. So replace this x with the given input. So 3 times x plus 1 minus 4. And then simplify this, 3x plus 3 minus 4. That is equal to 3x minus 1. So this is the output. That's the expression for, this is the expression for g of x plus 1. Okay, let's do another one, number 5. Okay, g of x plus g of 1. Okay, there are 2 functions added. So we're going to add the result of each function. So g of x is the question, g of x is 3x minus 4. So write it down, 3x minus 4 plus, okay, g of x is, g of 1. G of 1 is the input is 1, so replace x with 1. Then 3 times 1 minus 4. Then simplify. 3x, so minus 8 plus 1, so minus 5. So the result is 3x minus 5. Okay, this example is a piecewise function. Okay, f of x is a function, but this function has 2 expressions. One is x squared plus 1, the other one is x minus 1. We call this piecewise function. Okay, piecewise function is, okay, we can either use the first expression or the second expression depending on the input. So always check the input, and then if the input satisfies, then use the expression that satisfies the input. So if the input is less than 0, then we're going to use the first equation, first expression. If the input is greater than or equal to 0, then we will use the second expression. So, okay, f of -1, then x is -1. The input is -1. And -1 belongs to where? -1 belongs to the first. It satisfies the first condition, x is less than 0. So we have to use the first expression. So f of -1 is, we will use x squared plus 1. So f of -1 is -1 squared plus 1. 1 plus 1 is 2. So the value is 2. Okay, how about another example? F of 0. F of 0, then x is 0. Then this satisfies the second condition, x equals 0. So x is greater than or equal to 0. So we gotta use the function x minus 2. We have to use the expression x minus 2. So x equal to 0. So this satisfies this condition. So we have to use this expression. So f of x equals x minus 2. We have to use this. So f of 0 is equal to 0 minus 2. So the value is -2. Okay, how about this? How about trying this one? F of 3 plus f of, let's say, -2. Okay, then this one is equal to, the first function is f of 3. So let's find the value of f of 3. The input is 3, then 3 belongs to this second condition. So we have to use this. So we will use the second expression. So x equals 3 minus 2 plus, okay, for this value, x is -2. Then -2 satisfies the first condition. So we have to use the first expression, x squared plus 1. X squared plus 1. So x is -2 squared plus 1. Then 3 minus 2 is 1, plus 2 squared is 4, plus 1. So that is 6. So the value of this addition is 6. Okay, let's check the domain of a function. How to find the domain of a function? Okay, the example one is f of x equals x, and this is actually a straight line. Okay, straight line. Usually the x can be any real number. Straight line, for a straight line, the x value can be any real number. So the domain is all real numbers. Domain is all real numbers. How about example 2? Example 2, there's no restriction about the input value. The input value x can be any real number as well, because the graph looks like this, So we can use any x value. So x value can be any real number. So domain is also all real numbers. How about number 3? Okay, number 3, this is a fraction. If a fraction is, if the denominator of a fraction is 0, then this is undefined. Which means there is no value. We cannot find the value of this fraction, undefined. So there's a restriction in the input. The restriction is that the denominator cannot be 0. X can be any real number except those x values that makes the denominator 0. So if you set the denominator is equal to 0, then x will be 1. So if x equals 1, then the denominator becomes 0, and the fraction is undefined. So this is a restrict value. X can be all real numbers except x equals 1. So x can be all real numbers. X can be all real numbers, but x cannot be equal to 1. There's a restriction. So whenever there is a fraction, make sure that to find the x values that makes the denominator 0. So x is, the domain is all real number x except those x values that makes the denominator 0. Okay, how about number 4? This is a square root function, square root. Okay, if in order to have the real number as an output, the inside the radical symbol must be greater than or equal to 0. So this is a restriction. So all numbers, the expression inside the radical symbol has to be greater than or equal to 0. So this is the domain. Okay, the domain of a square root is inside the square root symbol has to be greater than or equal to 0. Then plus 1 each side, then x has to be greater than or equal to 1. So this is the domain. Okay. Usually we say the domain is all real numbers, but depending on the function, there is a restrictions on the input. So you may say the domain is all real number except x equals blah blah blah, depending on the input. So for number 3 and 4, if this is a rational expression, it's a fraction, then make sure those x values whose denominator becomes 0 is not included in the domain. Okay, for square root symbol, make sure this time the domain is always the inside the square root symbol has to be greater than or equal to 0.